Welcome back, guys. I hope you enjoyed. Welcome back, guys. I hope you enjoyed your spring break. Um, Moving on now into our 3D geometry stuff. This is actually 11.3, surface area of pyramids and cones. A pyramid is just a polyhedron, which is these shapes here, in which the base can be any polygon, and the other faces are triangles, and we're going to name them by their bases. So here, this sits on a pentagon. So the first one is a pentagonal pyramid. This either looks like a rectangle, so it's a rectangular pyramid. And this sits on a triangle. You can see the base right here. Sometimes they're hard to see. It can help to shade them. So this is a triangular pyramid. Okay. The triangles are the faces, and where they come together are the vertices. So this is our vertex. So here is a pyramid. The things that we need to know is what the big B is, the H, and the L, because we're going to be using these formulas. 1/2 LP for the lateral area and 1/2 LP plus big B for the surface area. Big B is the area of the base. So you'd have to use the appropriate area formula. Okay. H is the height. Now a pyramid and a cone are going to have two different heights. Okay, this is the height here, and they're always going to come down to the center and be a right angle. L here is the slant height. So what that is it's the height of your triangles that make up the faces. Okay, the height H is the height of the pyramid itself. L is the height of the triangles. And the last thing is P, which is the perimeter. So you need to know what these letters represent in order to use these formulas. All right, so what is the surface area versus the lateral area? Well, the surface area is just the area of all the faces and the bases of a 3D figure. So it is, if you're going to wrap a present, you use surface area. If you're going to paint the outside of a cube, you use the surface area. The lateral area is the area of just the faces. So in a pyramid, okay, it's not going to be the base. It's going to be these four triangles, which are all the same, by the way, and if it's a square. If it's other shapes, they're different, but that's going to be the lateral area. And a pyramid is everything but the base. In a cone, the lateral is everything but the base. Okay. In the prisms that you looked at yesterday, there were everything but the two bases. Right, so we want to find both the lateral area and the surface area of the following figure. So for lateral area, we've got a pyramid, and it's a square. We're going to assume it's a square pyramid. And so my lateral area is 1/2 LP. Okay, we don't have the slant height. We have the regular height, but not the slant height. We can find the slant height, though. Okay, because what we have is we have a right triangle here. Okay, and if this is a square pyramid with my right triangle, Okay, I've got a height of 15, and I've got this base is half the side of my square, so it's going to be 5. So I'm going to use the quadratic formula to find my slant height. So L squared is going to equal 15 squared plus 5 squared. So it's going to equal 125. So it's going to equal 125, which is 225 plus 25. So let me go back up here. So L squared is equal to 250. So L equals the square root of that, which is approximately, let's go with 15.8. Okay, so I know my slant height is 15.8. My perimeter, because this is a square, my perimeter is going to be 4 times 10. So perimeter is going to be just the perimeter of the base, so all sides are 10. If I add them all up or multiply by 4, it's going to be 40. So my lateral area is going to be 1/2 my slant height of 15.8 times a perimeter of 40. Okay, so if I multiply that out, my lateral area is going to be 316. Okay. Now the formula for surface area is 1/2 LP plus big B, which is the area of the base. So if you notice, this part right here is the formula for the lateral area. So you've got this almost all done already. So my surface area, we said that this was about 316. The area of the base, it's a square, so 10 squared, so 416 is my surface area. And if I use correct notation, it's inches squared. All right, let's look at the next example. Or actually, let's talk about cones. Cones, very similar. Again, we have the slant height, and we've got the regular height and the radius, and those are the things that we need to know in order to find the lateral area and the surface area of a cone. So the lateral area is everything except for the circular base. Okay. This cone is an oblique cone just because it's pushed over just a little bit, and the formulas for oblique and regular right cones are the same. So the lateral area is pi RL, and it looks like we don't have the slant height. So, and actually, we're not going to be able to find, well, let's make something up here. All right, so let's say that this is 20. Okay, or no, it can't be 20. Let's make that 8, because the whole thing is 28. All right, so we'll make the base of that triangle a 8. So to find my slant height, again, we're going to use the Pythagorean theorem, 8 squared plus 25 squared. So 64 plus 625 is going to be 689, if I did my arithmetic correctly in my head, which you guys know I don't all the time. And it is, and the square root of 689 is about 26.2. Okay, so now my lateral area is going to be pi times the radius, and the radius is 14 because it's half the diameter, times the slant height, which is 26.2. So if I multiply that out, 14 times 26.2 is going to give me 366.8 pi. And I'm just going to leave it in terms of pi because that's the directions don't tell me what to do. And you guys know me, I'm going to make it, I like it simple, especially when I'm the one doing the work. When you guys aren't, we can make it a little harder. Okay, surface area is pi r squared plus pi r L. Okay, so again, notice we've got the lateral area as part of the formula. And then look at this, pi r squared, well, that's the area of the circle. So my surface area is going to be, the radius we said was 14, so 14 squared pi plus 366.8 pi. And 14 squared is 196. And if I add that together, that's going to give me 562 and 8/10 pi. And all I did was add the coefficients. And I'm just going to leave it like that because that's all that I asked you for, or I didn't specify. All right. Here I've got a composite figure that I need to find the surface area for. But what I want you to notice is that what we really need is the lateral area of the cone, because the base of that cone is connected to one of the bases or one of the sides of the cubes. It's a cube because all three sides are the same. So really, for the pyramid, I just need the lateral area. So we can find the lateral area of the pyramid. And in order to find the lateral area of the pyramid, I need that slant height again. So got to use the Pythagorean theorem to find that. So L squared, this is 5, and the height is 13. Or actually, yep, that's right. All right. Actually, it looks like the 13 is this side right there. So now when I make my right triangle, it's still going to be 5, but that 13 is the hypotenuse because it's the edge. So for my slant height, it won't be the hypotenuse this time. So it's 13 squared equals the slant height plus 5 squared. So 169 equals L squared plus 25. If I subtract, I'm going to get 144 equals L squared. So L is 12. Okay. So my lateral area of my pyramid is 1/2 LP. So 1/2 12, and the perimeter is a square with all sides 10. So 40. So my pyramid is 240. Okay, so that's for my pyramid. Now for my cube, you learned the day before, the prism, the formula that they gave you was the height, the perimeter, plus 2 times the base. So for the surface area of the cube, the prism, it's height times perimeter plus 2 times the base. Okay, well, we only need one of the bases because one of them is covered up in our thing, so it's going to be times 1 times the base. So our height is going to be 10. The perimeter we said was 40, so the height connects the bases, and it really doesn't matter, all of them are the same. So 10 times 40 plus the area of the base is 10 squared because it's a square. So we've got 400 plus 100 is 500. So that's the surface area of the cube minus one of the bases. So when we add these together, my surface area of everything is going to be 740 square meters. It's a thinking one, huh? All right. So here, in this example, we're going to do some other things going on here. We said the length of the side of the base, slant heights, and all of this are given of a square pyramid. So we want to find the other three to the nearest tenth. So we're given the height and the slant height. So we need to find the side, the lateral area, and the surface area of a square pyramid. Okay, so if I have a square pyramid, I can draw this. I'm not the best at drawing. Okay, so there's my base. I've got a height of 7, and I've got a slant height of 25. So that little magic triangle in there has a height of 7 and a slant height of 25. So in order to find the side, since it's a square, all I have to do is find this side right here and double it. So again, the Pythagorean theorem is our friend. So x squared plus 7 squared equals 25 squared. So x squared plus 49 equals 625. And 625 minus 49 is 576. And if I take the square root of 576, I get 24. So my x is 24, and since it's only half of that square, it's going to be, my side is going to be twice that, which is 48. And now that I have that, I can find all my other sides by using the formulas. So the lateral area is 1/2 the slant height times the perimeter. So my slant height we were given was 25. The perimeter, if one side is 48, 4 times 48 is going to be 192. Sometimes I do all of this scratch work off to the side. So then my lateral area is going to be 2,400 square centimeters. And then my surface area, to find that, it's 1/2 LP plus the area of the base. And so we already have our 1/2 LP, which we said was 2,400. Square is going to, the area is going to be 48 squared. So it's going to be 2,400 plus 2,304 for a grand total of 4,704 square centimeters. All right, so just a lot of moving back and forth and thinking. So just as a recap, okay, we looked at pyramids and cones today and their lateral area, which is the area without their bases, and their surface area without the bases, and your surface areas. Have a great night.